Hi guys. I'm going to go over each of the questions that you guys asked me to go over. Even though we did get a single request for a couple of the other ones, for the most part, the common ones I saw were basically just 14 till the end, which I guess is 20 or so. So I'm just going to do those. So we're going to start with number 14. And I'm hoping, this is what I'm going to do. I'm going to explain each of these, explain a little bit about the topics along the way, but then when I kind of pick up what it is that you guys are struggling with, I'll make individual topic videos basically on that idea so that we can go from there. All right, I'll shut up and let's start. So number 14, we have three resistors. R1 is 3 ohms, R2 is 6 ohms, and R3 is 9 ohms. I'm just going to write that here. So we have 3, 6, and 9 ohms. And they're connected in series, meaning they go one after another with each other, and they're connected to a 36 volt battery. What is the ammeter reading after the switch is closed? Well, so when they say after the switch is closed, before it's closed, the ammeter is reading 0 because there's no current traveling because we don't have a complete circuit. So when we close the switch, we're completing the circuit. So now what is the current that goes through it? So there's two steps that you have to do to figure this out. Step number 1 is we need to find the equivalent resistance. Equivalent resistance is kind of like the total resistance. The reason why we don't say total is because we could technically take these two, smush those two together and find the equivalent resistance of those two. It wouldn't be the total resistance, but it would be the equivalent resistance of those two resistors put together. So that's why we call it equivalent resistance. In this case, we're smushing all three of these together. So it's basically the total resistance. So that's step number 1. And then step number 2, we're going to use Ohm's law. Ohm's law says that the current moving through a circuit is equal to the total voltage across that circuit divided by the total resistance over that circuit. We could also use it individually, so the current through a resistor is equal to the voltage across that resistor divided by the resistance of that resistor. But since we're talking about the whole circuit, we're going to talk about the whole circuit for this. So let's go back to step 1. REQ, equivalent resistance. So the way that we solve it, when we have a series circuit, we just add them up. So REQ is R1 plus R2 plus R3. There's 3 resistors. So that's going to be 3 plus 6 plus 9. 3 plus 6 is 9. 9 plus 9 is 18. And that is our total resistance in the circuit. Cool. Next we go on to Ohm's law. The current, which is what we're looking for, is equal to the voltage divided by the resistance. So the voltage is 36. The resistance is 18. 36 divided by 18 is 2, and that's current, so it's amps. So the answer is 2 amps. By the way, if you see that my thing has that it's wrong, that's because I went through and just picked A for each of them so I can get all the questions and see what you guys are talking about. The only other thing that I will mention here is that is the current through the entire series. So here's the positive side, meaning it's going like this. The current that's going through this ammeter is the same current that's coming from the battery, is the same current that's going through resistor 1, resistor 2, resistor 3, and resistor 3, and then going back to the battery. At any point that you pick on this circuit, when the switch is closed, the current is 2 amps everywhere. All right, that's something about series circuits that you guys need to understand. All right, so that's question number 14. Here's question number 15. We have 3 resistors. R1 is 5, R2 is 3, and R3 is 4. And they're connected in series, that's important, to each other. A voltmeter is connected in parallel to resistor 2, just like that, and measures a voltage of 6 volts. What is the current through the battery? Okay, so the current through the battery is what we're going for here. Okay, so here are the steps that we're going to take. Let's use blue. So our ultimate goal is we want to find out what is the current through the battery. We don't know what the voltage of the battery is. That's part of the issue, right? we could add up all the resistors and get the equivalent resistance, but that's not going to give us the voltage of the battery, so that's part of the issue there. Here's what we can do. Step one is we're going to use Ohm's law, and Ohm's law is this. And what we can do is we can do it just for resistor 2. So we're ignoring everything else that's in this circuit. We're just looking at resistor 2. So this is the current that's going through resistor 2. This is the voltage across resistor 2. And this is the resistance of resistor 2. You can do that with Ohm's law. You can pick either the total circuit and make all of these totals, or you can just pick an individual circuit element like a resistor or a light bulb or a battery. Alright, so then the current through that resistor is equal to the voltage across it, which is 6, they told us in the problem, and then the resistance of R2 is 3. So the current is 2 amps. Now, that's it, that's the answer, because again, it's a series circuit, which means that anywhere you pick, the current is the same. So if we know that the current is 2 amps here, then it must be 2 amps here, 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 everywhere. All right, so 2 amps is the answer. And all I had to do was use Ohm's law to figure out what the current was through resistor 2. And I knew that the current through resistor 2 must equal the current everywhere else. So that's how I knew to solve that problem. Here's question 16. 3 resistors, R1, 5, so we'll write these in, 5, 3, whoops, let's write it up here. 3 and 4 are connected in series with each other. A voltmeter is connected and has a voltage of 6. What is the net voltage in the circuit? Alright, now, in question number 15, we learned that the current was 2 amps, and we know that the current is 2 amps everywhere, right? And if you didn't remember that, you could solve for it all over again if you wanted to, but if not, just go back and check it. So that means that we can use Ohm's law. Step 1, we're going to use Ohm's law to find the voltage in, or I should say not in, but across each resistor. Now, I had a question from the group, and the question was, how do we know like which equation to use and when? And I always answer that question in any physics topic anywhere. You can use an equation to solve for anything that's in that equation. So if you look at Ohm's law, we have current, we have voltage, whoops, and we have resistance. So if you're looking for, whoops, I didn't spell that right. If you're looking for any one of these 3 things, especially if you have the other 2, then you can use Ohm's law to find it. You know, it's basically kind of like when you're answering a physics problem, you ask yourself, what do I have and what do I need? And which equation has all of those things? So in this case, I need to know what is the net voltage. The only way to get net voltage, net just means the sum of all the voltages, is you have to get the voltage across 1 plus the voltage across 2 plus the voltage across 3, right? So that means in order to get the net voltage, I need each one of these voltages. So then therefore I need to get the voltage across each one. I know the current, it's 2 amps in every scenario, and I know the resistance, so I can find voltage no problem. So for R1 it's 5, so V is going to equal 10 for that's 1, and then for R3 it's V over 4, so then V is going to equal 8 volts. So what that means is, if I'm going to use, let's use red for voltage, if I put a voltmeter across R1, it's going to read 10 volts. If I put a voltmeter across 2, it's reading 6 volts. And if I put a voltmeter across 3, it's reading 8 volts. And so now the question is, what is the total voltage, or the voltage in the battery, which it should equal? And it's just going to be 10 plus 6 plus 8, which is going to be 24 volts. Oops, right there. Oh, right there. There you go. So step 1, Ohm's law to find the voltages. Step 2, net voltage just means the sum of all of the voltages, right? Net means the sum of. Okay, now the first couple questions I did were about series circuits, and series circuits kind of have some of their own rules and own concepts and tips and things that we've been doing. For parallel circuits or branches of circuits, they're a little different, so we're going to start seeing these now, I think. So we have two resistors, R1 is 3 and R2 is 6, and they're connected in parallel. Important. What is the net resistance in the circuit? So to find the equivalent resistance for parallel circuits, use this equation. 1 over Req is equal to 1 over R1 plus 1 over R2 plus however many more resistors you have in parallel. So what that means is to find the equivalent resistance for a parallel circuit or Req, I would just do 1 over Req, which is what I'm looking for, is equal to 1 over R1, which is 3, plus 1 over R2, which is 6. Now, I'm going to stop right now because I remember you guys, I know it's been a while since I've seen you, but I remember a lot of you guys struggle with algebra, and those people typically also struggle with fractions. I'm going to explain something to you. You cannot just flip everything and just say Req equals 3 plus 6, right? Because you're like, oh, I'll just flip that, and I'll flip that, and I'll flip that, and then I'll get that. And the answer is 9. That's not right at all. You cannot do that. So don't do that at all. That's algebraically illegal. My recommendation is, usually it's pretty simple to find the common denominator. So this is 1 over 3, this is 1 over 6. So the easiest thing for me to do is say 1 over 3 is the same as 2 over 6. And now I can add these together. You cannot add these together and say that this is 2 over 9. That's not correct. You have to get them to have the same denominator before you can add the tops, right? So now they have 6's by converting 1/3 to 2 6's, and now I have 3 over 6, which is equal to 1/2, right? Now we're going to stop again because this is the second mistake that my students make. They say, oh, 1/2, that's my answer. That's not your answer. 1/2 is equal to 1 over Req, but I want Req. So once you find your answer, then in order to get Req by itself, then you can flip them both, right? So if I flip that, I have to flip that, so then I get Req is equal to 2 ohms. One way to check your work is that when you're using parallel circuits and finding equivalent resistance, the equivalent resistance should always be less than either one of these. So 2 is less than 3, so it's probably right. So the answer then is 2 ohms. All right. This equation is the equation to find the equivalent resistance in parallel. Series is easy. You just do R1 plus R2, etc. That's for series. But for parallel, it's just a little bit more complicated with the fractions. All right, we have question 18. Two resistors R1 6 and R2 12. So let's write that in. R1 6, R2 12 are connected in parallel to each other and in series to R3, which is 2. What is the net resistance in the circuit? Okay, we're going to stop here, take a breather. Number one, this kind of circuit is a complex circuit, meaning, or a mixed circuit, whatever you want to call it. Meaning that it has elements that are in parallel and it has elements that are in series. I'm going to draw all over this real quick just to show you. Current's coming here, whoops. Current's coming in here. At this junction it splits, right? It can either go that way or it can go this way, right? I should probably make this a different color. Alright, so those are the two options it has. When it gets back here, then this is in resistance, sorry, this is in series with this, right? If I were to draw this and smush these two together, it would look like this. That and then R3. So this would be R3. This would be R equivalent of R1 and R2 smushed together. So these two are in series. Sorry. And this is a complex circuit. So that's just the first thing I wanted to show you. All right, so let's just go back and restart now. So now that we can see that, this is 6 and that's 12 and that's 2. What's the net resistance? So what we're going to do first is we're going to do the more complicated thing, which is we're going to do the parallel one first. So 1 over Req is equal to 1 over R1, which is 6, plus 1 over R2, which is 12. Now, 1 over 6 is equal to 2 over 12. So that means that I have 3 over 12, which simplifies to 1/4, but that's equal to 1 over Req. So that means that Req, if I flip them both, right, do the reciprocal of both of them, then I get 4. So what that means is if I redrew this circuit, this is the first one smushed together, this is R3, this is R equivalent of, it's basically 1 and 2 smushed together. This is now 4 ohms, and this one is 2 ohms. So when I smush those two together in series, R equivalent is just going to be 4 plus 2, which is 6 ohms total. So the correct answer is 6. Alright, this is question number 19, and we have the same sort of setup with the parallel going on. We have R1, R2, R3. R1 is 6 ohms, R2 is 12 ohms, and R3 is 2 ohms. There's a couple ways we can tackle this problem. I think the easiest way to tackle the problem is to figure out what the total resistance is and then go from there. So like number 1 we find Req, and then number 2 we use Ohm's law to figure out what the net voltage is. I think that makes the most sense. So for example, Req is we have to smush these together again. So I think we already did this in the last one though. And to be honest with you, I took a break to eat dinner, so I kind of forget. So we'll just do it all over again. So it's just 1 over Req equals 1 over 6 plus 1 over 12. That's going to be 2 over 12 plus 1 over 12, which is 3 over 12. That's going to equal 1 over 4. So then Req is going to equal 4 because we got to flip both of those, right? Flip that and then flip that. So these two smushed together are going to be 4 ohms. Then we have 2 ohms, so the Req is 6 ohms. And if we know that the current going through this one is 3 amps, then voltage is equal to, this is Ohm's law by the way, voltage is equal to the current times the resistance. This is the total voltage is equal to the total current times the total resistance. I know the total current is 3 because that's when they're back together. If we knew the current here, that wouldn't be the total current because some of it split off to go through R2, some of it went to R1. Because I know it's here at R3, I know it's the total current. So I just plug in 3 there times the total resistance, which is 4. Wait, did I do that right? 3 amps. Oh, that's the Req of that one, 6, my bad. 3 times 6 gives us 18 volts. So that's what makes 18 volts the answer. I'm going to real quick show you a different way to do it. It's a little bit harder, so you're probably going to skip it. But just in case you're interested, you might learn something. So I'm just going to erase everything real quick. So the other way that I would do this, honestly, is if I know that this was 3, right, then, and the R1 is 6 and R2 is 12. The way I like to think about resistors, oops, that's amps. The way I like to think about resistors is thinking of them like toll booths. And instead of 6 ohms, you can think of that as a $6 toll. And instead of 12 ohms, you can think of that as a $12 toll. Now, if cars are coming and they have an option, they can either go through a $6 toll or a $12 toll. Most of the cars are going to go through the $6 toll. But you guys know, you know some rich people, maybe you're some rich people, you know that some people are going to say $6, $12, I don't care. There's nobody in this line, even if it costs me $12, I'm going to go in that line. So some people go through the 6 because they're like, yo, that's cheaper. Some people go through the 12 because they're like, you know what, 12 isn't that bad. But what they do is the current, or the cars, the traffic, splits proportionally. That's a scary word for just saying if you have 6 and 12, that means that double the current is going to go through the 6 and half the current is going to go through the 12. So if we know that 3, so I'm going to redraw this real quick. So we know that this right here is 3, that's the total, then the current at the top has to be 2 times the current at the bottom, and it has to add up to 3. So that means that this can be 1 amp and this can be 2 amps. So 2 times the traffic goes through the $6 toll because it's cheaper. 1 time, or half of that goes through the $12 toll because we do have a section of rich people that'll just be they'll be like $12, I don't care. So if we do that and we know that that's 2 and that's 1, then what we can do is we can use Ohm's law to find out what the voltage is across each resistor. Actually, we only need to pick one. Let's pick the top one. So the voltage across the 6 ohm resistor is going to be, we'll call this V1, is going to be the current across that one times R1. So V1 is equal to the current, which we said was 2, times R, which is 6. So that's 12 volts. So that's 12 volts up here, and then this is 6 volts here, as determined earlier, right? Because V equals IR, so V is equal to 3 times the resistance there, which was 2. So that's 6 volts. So if this one's 6 and this one's 12, the net is, you just add them up, right? Net voltage, just sum them up, so you get 18. I feel like that's probably going to be harder for most of you because you have to think proportionally in order to figure out what the currents are. So I get it, but it's a nice exercise to think about. All right, and this is the last one. Same setup again. We have 2 resistors are connected in parallel with each other and in series with blah, blah. So same thing. So we have 6 and 12 and 2, and that's still 3 amps. And they want to know what is the current in the 12 ohm resistor. This is the 12 ohm resistor. So yeah, I kind of actually just did it 1 amp. I did it in the last problem, so if you didn't skip past that, you can actually see how I figured that out. I guess now that that's the easy way to figure that out. So I'll explain it one more time real quick. If you look at these as paths, this resistor is half the strength of that resistor, right? Because this is 6 and that's 12, so that's 1/2 of this one. So if we have 3 amps coming here, that means that the sum of both of these currents have to be 3 amps. That's called the junction rule. The junction rule just says that the current in must equal the current out. The sum of the currents in must equal the sum of the currents out. So for example, if I had 10 amps coming here and then 12 amps coming here, then this must be 22 amps, right? There's no way that this could be anything else because that would mean that we're either creating current or we're destroying current, which is not allowed. So anytime you see a junction, which is a place where current can split or come back together, the current in must equal the current out. So if we have 3 coming out here, that means that the sum of these two must be 3. And basically just works proportionally, where if you have, let's think about it like this. Let's make it, instead of half R, let's make this 2 times R, right? This one is 2 times bigger than this one up here. So if this is 2R and this is R, we basically need to know what is the current? One's going to have double the current, and that's going to equal 3 amps. So basically one's going to be, actually ignore that, that's confusing. Basically what plus what equals 3, where one thing is double the other. And so that would be 2 plus 1 is equal to 3, because 2 is double 1, right? So that's how you would figure out that there must be 1 amp of current going through that one and 2 amps of current going through that one. That's like the shortcut way, but that also requires that you can think through this proportionally and logically using some, you know, I guess it's advanced math for, it's not advanced math, it's advanced thinking and problem solving for freshmen, I would think. So let's go through the systematic way, the step-by-step way, to make sure that you get it right and you don't have to use all that fancy thinking. Instead, what you can just do is, we knew that the total voltage was 18 from the last problem. We also know from earlier that the total resistance was, I don't even remember. Do we even need it? I don't know. We have the resistors of all of those. We have the current. We know the total current is 3. So yeah, that would make the total resistance would have to be 6. Yeah, that makes sense. So we know these things already from previous problems, and we want to know what is the current going through R2, which is the 12 ohm resistor. We know it has to be less than 3 because it's 3 here. And the way that I would do it is, you know the total voltage is 18, and the sum of all the voltages has to add up to 18. So we have, this one was 6, right? Am I remembering that right? I think so. And so 6 plus what equals 18? It's 12, right? So that means that across both of these is 12 volts. Now, for a parallel circuit, ignore that last one. For a parallel circuit, the voltage drop across each branch is equal. That's an awful circuit. I don't know why I drew that. So here, put a battery there like that. There we go. So let's say the battery was 12 volts here. That would mean that across each one of these, across here to here, that would be 12 volts. Across here to here, that would be 12 volts. Across here to here would be 12 volts, and across here to here would be 12 volts. So across each branch in a parallel part, the voltage is the same. So it's 12 volts across R1 and 12 volts across R2. So if it's 12 volts across R2, the voltage for 2 is 12. The resistance for 2 is also 12. So then the current will be 1 because of Ohm's law, right? Or if I use I is equal to V over R, I is equal to 12 over 12, which is just 1. So that's our answer. Hopefully that helped you. I'll explain a couple of different things in the like in a general video, but these are just the answers to those problems.